All right, welcome back to DellyMaths Concepts. What we're looking at today is we're continuing to review CXC questions, seeing that the exam is coming up. All right, please like the channel, subscribe, like this video should say, subscribe to the channel, and share the video so others could find it. All right, so we're going to be looking at geometry and trigonometry. Just a question here. So let us take a look. It says, in the diagram below, ECGF are points on the circumference of the circle. EG is a diameter of the circle. The tangent AEB is parallel to CD. Angle AEC equal to 68 degrees. And EFD equals 106. All right, so the diagram has all the information that we just read. The first question says, determine the value of each. All right, so we're getting a number of angles. We're supposed to give the value and then give the reason as well, right? So let us start. Let's go. All right, so the first question says we want to find the value of the angle ECD, and we want to give the reason right there. EC. Normally what I do is to mark the angle. So I'm going to line it first. ECD. So from E to C, going to D. And the angle is going to be the middle letter. So we want to find that degree of turning right there, right? So we are right here. As you could see, we were told that these two lines are parallel. This line is parallel to that line. We got that. So because the lines are parallel, right? When parallel lines cut by a transversal. So here is a transversal right here. When two parallel lines are cut by a transversal, we have a lot of relationships going on. One of which is going to help us know is the alternate angle. We call it the Z angle. So this angle is also 68 because Z angles are equal. So you could see this so-called Z here. So we are inside the parallel lines. That's one. This is the other. This is the other. So this angle is that angle over there, right? So it's called Z angle. So that is 68. Proper name for it, alternate angle. So the reason is alternate angles are equal. And the idea is they're only equal when they're between two parallel lines. So that's the concept. We're dealing with parallel lines right here. So that is 68 degrees here, right? As you could see. Now let us move forward into the other question. The other question says, want to find angle CEG, CEG. So again, from C to E to G. So we are looking for this. C0, E0, and G0. Following those three letters, our angle is going to be at E. Remember, though, that when a diameter or radius hit a tangent, we're going to get 90 degrees. So there is a 90 degree at point E right there where the diameter intersects the tangent to the circle. There's a 90 degree down there. So now we're going to utilize that fact to work out the missing angle that I want right here, because we can simply say 90, right? So basically the 90 degrees, if I take out the 68, I'm left with about 22. So it's about 22 degrees. So let's take a look at it again. The entire angle here is 90. We got 68 out of it, so the remaining piece is 22. So what's the reason? We could put it together. Together that the angle formed between. So I'm just roughing this up. So I'm just gonna say angle between. So basically, I'm saying the angle formed between the radius and the tangent, and we're referring to at the point of tangency, is 90 degrees. So the angle formed between the radius and the tangent is 90, and we utilize that as our vehicle to go forward. Thirdly, we want to find the value of the angle CGF. Let's mark the angle CGF. So you're moving from C to G and then F. Let's clear this up quickly. CGF. So CGF is actually all of this angle right here. CGF. All right. Now, so what's going on here is that earlier on, we were given some ideas, right? Earlier on, we were given some ideas. We were told that C, G, F, and E, they were on the circumference of the circle, which would have made this circle, this shape that I'm about to outline. It is a cyclic quadrilateral. So we're going to utilize the idea of the cyclic quadrilateral to solve this problem. All right, so let me clear up the diagram again. All right, so clearing up the diagram. So now, remember, I need this. One of the things that we can look at is this is 22 right here. Now, remember the parallel lines we have. So it would have made that this is 106. All of that is 106 because alternate angles are equal. So with that fact right there, right? I am able to find this piece right here, and then I'm going to do something. So let's find it first, and then we'll talk about what we want to do. So we're dealing with the angle CGF, right? That's at number 3. So the first move that we're making here is to say, guess what? 106 subtract. We could have subtract 90 from it, right? Yeah. 106, take out 90 out of it, which is 68 plus 22. So that's exactly it. It's about 90 there. And it would have given us, let me see how much we get. All right. It would have given me this to be about 16. All right. So because that part is 16 right there, I now have all of this angle right here, which is 16 and 22. So let me take off about this just to clear up stuff. So now we know that that is 16 and 22. So together, this is about 38 right here. So this is 38. So now that I know that that angle at E is 38, remember though, opposite angles in a cyclic quad is supplementary, which means they had to give 180 degrees. So then what we're going to do is that, so I'm just putting normality working here so you could see how we'll get the 38 right there. So then it's going to be 180, and we want to take out that 38 out of it, right? So if we take out 38 from 180, we're going to be left with 142 degrees. Because opposite angle in a cyclic quad is supplementary. So the moment I was able to find my 38 degrees right there, I'm able to now use it to go across, diagonally across from it. And then we would have gotten that. So that's that. Now, what reason we could have written? Well, we could have written the fact that opposite angles in a cyclic quad or quadrilateral is supplementary. And by that, we mean that it adds to give 180 degrees. So it was on that fact that we worked that out. All right, so that's the answer to that question right there. All right, so we just found this one, which is 142 degrees. We're going down. Okay, so we're done with that. We're in another question. So it says from arbor H, the bearing of two ships Q and R are 69 and 151 respectively. 69 is on the thing, so it's 151 that is missing from the diagram. Q is 175 km from H, while R is 242 from H. All right, let's see what they want. First question, complete the diagram above to show the information given. So there's only two things missing here. We're missing the length from Q to H, and that was given as 175. We were told that right here. So this piece here is 175 km. And this bearing is missing, and this bearing is R from H. So all of this turning coming all the way around is going to give us 151. So that is all of 151 degrees. Now, that's that bearing coming around there, right? Now, so we completed the diagram, we're good. Calculate QR, the distance between the two ships in kilometers, to the nearest kilometers. So they want us to calculate QR, which at all times the bearings questions, they tend to go across like this. So we want to find that distance. So if we're going to find that distance, we need to find this value here. But because the two bearings came from the same H, so they overlap. So we can simply find this missing angle here by subtracting the 69 from the 151 since they overlapped. And it's going to give us that the value of this angle here is 82. So let me just drop 82 right here. So this value here is 82. All right. That means if you should add 82 plus the 69, you're going to get 151, which would have been the total thing there. So that is what we did there to get that. Now we're going to use the cosine rule, because remember the cosine rule says if I have two known sides like what we have here and an angle between them, we are able to find the side across from that angle. So we're going to start off by saying QR squared, and the formula is like this. It's equal to 175 squared plus 242 squared minus 2 times 175 times 242, the cosine of 82 degrees. All we're going to do is just to put together some numbers. We're putting together our numbers. When we square 175, we're getting 30,625. And when we square 242, we're getting about 58,564. All right. So normally what I do is, this is all multiplication here, which means that all of this must go on your calculator at once to know what this value is, right? So you want to start off with -2 times 175 times 242 times the cosine of 82 degrees. And it's going to give us negative 11,787 point some stuff. So let's write this. So it's 11,000, negative 11. So we're subtracting 11, 787.9. I'm gonna put 96. It's 9. That's not 7. So this is a 9, 6, 2. All right, so I'll stop there. So let's finalize this, right? Let's finalize this. So 30,625 plus 58,564. And we're taking 11,787.962. All right, I'm getting some 77,401 basically 0.03 and 8 and so on. All right, so in terms of to find QR, we're gonna have to take the square root of this number. So let us take the square root of this. 77,401.038. All right, so my answer for QR is actually 278.21. But the question did say to the nearest kilometer, so it's going to be 278 kilometers, because this number here will let us round down. So this side here is 278 km. All right, so we have that down. That's to the nearest kilometer. All right, so normally I would advise you to label the diagram as you go forth. You label the diagram because what it does is it gives you insights into the other question that is coming. So you put it on the diagram as I've done here. Let me clean up the unnecessary stuff on it like these. All right, clean off these and so on. Right. So, all right, let me put back the 175 here. All right, there you go. All right, now let's see what the other question is about. So the other question says calculate, is it this? All right, yeah, we're there. It says calculate how far due east is the ship R from the harbor H. So when we say due east now, we're thinking of traveling. So how far due east, which means that we're gonna have to travel from H. Let me get a bigger pen. We're gonna come here. We want to know how far do we come this way, such that we're going to be lined up exactly. We're going to come down this way so we could line up exactly to connect with R. So that's the idea. So this is how they would put it though. All right. So how far do we come south to line up? But the moment we're going to come south to line up, we're going to have to go east, west, or so. So we're going to go east in this context, which means that we're going to have a 90-degree here. So the moment we're dealing with south and east and west, we're going to have 90 degrees, which means that I just need to find this angle here. Because remember, I have the hypotenuse already. So how would I find that angle at H? All right. How would I call it? So if I should just call this anything H, how would I find the angle at H? If I want the angle at XHR, I'm going to have to say 180. I'm going to take 151 from it. And it's going to give me about 29. So this is 29 right here, right? So because I know that that is 29, then I'm able to use that to find the adjacent side, which is this that we want. And we have the hypotenuse leg right here. So which one of those trigonometric ratios would have included the adjacent and the hypotenuse? Is going to be cosine. So it means then we're going to have to use, I'm going to put it over the side here. All right, let's put it over the side here. So for that, what we're going to do is to use cosine. Remember though, that cos of the angle is going to equal to the adjacent side divided by the hypotenuse side. So cos of 29 degrees is equal to, I'm going to call it XH, all right, over the hypotenuse, which is 242. If we just simply multiply both sides, just going to do it so we could look at it. If we multiply both sides by 242, you'll see that it cancels. So in other words, then XH, which is that distance that we want, is 242 times the cosine of the angle 29. And it's going to spit out our response, right? So our response is about, all right, so I'm getting 211.657, and it goes on. But the question is, I think we're rounding off this to the nearest. Let me look again. How far do we? All right, basically, I'm going to round this off like this other one here to the nearest kilo. So, so we could just call this. All right, so basically this is 212 km to the nearest km. But this is the definite answer right there. But to the nearest km, it's 212, which means that if you travel 212 km south, you're going to line up such that you could easily approach R going east. All right. So basically, that's what it is, right? Now, let's see if we have another question. Oh, it's done right there. So that is geometry and trigonometry. See you next time, DellyMaths Concepts. Bye-bye.